So, what are we going to do with all this data? This is a question that we get asked a lot. It's also a question that we ask ourselves a lot. And basically, we've been instrumenting a lot of different elements of the structure. We've been instrumenting, the beams as they've been manufactured off-site. We've been doing on-site instrumentation of the structures. We've been gathering a lot of data with two different systems. And the question is, so really, where is all of this going? And we've at the most basic level, we have very specific specific research questions that we're trying to address. So for example, with the concrete bridges, we're trying to look at things like the pre-stress losses in the beams. And with the steel bridges, we're trying to look at the effects of composite action on the demand placed on the main beams. But those are very design-specific questions. However, we're also trying to build up, as we go through the various different construction stages, gathering data, well-validated finite element models that have been validated alongside the different construction stages so that we can also carry out parametric and predictive studies for the structures. But then moving up a level, as already mentioned by Niamh, we're also interested in tracking the load as it is transferred down through the structure. So we're trying to look at the load from the point of application at the sleepers, down through the deck, along the main beams, and see how the structure is actually behaving under the live loads. But what's the bigger picture? What are we aiming to contribute to the instrumentation and monitoring of bridge structures in a broader sense? And there's two bigger goals that we're trying to achieve, both of which are tied together ultimately by trying to increase the viability of bridge monitoring systems. And in order to think about this, I wanted to ask, based on the Pecha Kucha format, what can you get from 20 seconds worth of data? And of course, the answer to this depends on your sampling rate and, of course, the frequency of what you're trying to measure. And this is really the key to the systems that we've installed. We can sample at a very, very high rate. And so this means that we can look at our strain data and start to do the dynamic monitoring and characterization work that would traditionally be carried out with accelerometers. And in this sense, we're essentially trying to consolidate two traditionally distinct areas of monitoring, dynamic monitoring and strain monitoring. Following on from this, if we are successfully able to characterize the live loading and provide network level data on bridge traffic, it means that we can get extra value out of what is a very labor intensive and expensive monitoring system to install. Moving on from this then, the other big picture idea that we're trying to pursue is that essentially as construction moves from on-site, in-situ construction more towards off-site prefabrication, what we would like to do is see the off-site prefabrication of the sensing elements as well, so that these can then be brought onto site pre-instrumented. And we have two examples of this on our project. The first is the pre-stressed beams. And this is them arriving on site, which is a great day for us and quite a bit of excitement. And then the other is the pre-stressed concrete sleepers. And the sleepers the concrete elements really lend themselves very well to this because of the ability to embed the sensors. And I'm just going to break with the Pecha Kucha format for 2 minutes to show you a little how it's made video of our pre-stressed concrete sleepers. So you can get an idea of what it takes to basically do this off-site and see the potential that's there to achieve this. And it's got lots of cheesy music. So this is us installing the sensors along the pre-stressing strands. You can see we've just attached them with little cable ties. That's how we exited them out of the end plates to give them a little bit of protection, because obviously they're going to be going into a very demanding environment. And essentially there's just a couple of shots here of the concrete hoppers coming along and pouring the concrete in. And this was a very gentle process for the sleepers. It was the concrete went along at quite a slow pace. And then moving on to a bit of the drama of demolding our instrumented sleepers. It's just taking off the end plates, which is actually really the most vulnerable aspect of the whole operation, despite the sort of the sparks flying with the axle grinders. And this is a machine which just cuts the sleepers along the different beds that they're all cast in. And then they were lifted out and the pre-stressing strands were ground off at the ends. And that's essentially them there, sort of all finished and ready with the fiber optic cables wrapped up. And then we brought them into the lab and did some load testing at the rail seat up to the first crack in the sleeper, and then back down again and cyclically loading it like that. So again, just to thank our industry partners, there's been a lot of different involvement from various different parties. In particular, we'd like to thank Atkins. Ruth Platt has been leading us through the design of both of the structures in quite a bit of detail, and we've had excellent support from Lang O'Rourke out on site, both at the Explore manufacturing facility and at the Norton Bridge complex. And then we've obviously been working quite closely with CEMEX. We're going to be carrying out testing of the sleepers up at Harriet Watt's facility. And then, of course, we've also had enormous internal support for the project as well. Thanks very much.